Hello, everyone. So yeah, that's me. That was name dropped in the previous talk a couple times. So in this talk, I'm gonna present two bugs. One was about 10 years ago, which was my first real Rails contribution. And another one that was just like a bit more than a year ago. That was probably one of the, if not the hardest, the most intricate bug I ever had to fix. But first, let me introduce myself. So Jean Boussier, probably better known as Beirut. If you follow Ruby or Rails development, you might see me as my professional alter ego, which is a Casper is fine. And in addition to being part of Rails core and a Ruby committer, I also maintain a number of popular gems, such as like a Bootsnap, Redis client, message pack, a few things like that. I probably don't need to present my employer. I'm sure you're all streaming music on your phone. So yeah, as I said, the first bug was from 10 years ago. So like every bug, every contribution, there's always a context of an opportunity. Back in the day, I joined Shopify in October 2013. And it was their newly created office in another town. So we were growing very, very fast. We were assigned projects, but there was always more people than work to do. So that's why I just try to keep myself busy, looking at all the issues on the bug tracker and starting to fix weird stuff. So I made a bit of a reputation for myself. Until one day, my manager just told me, "Hey, Jean, I have something for you." And so, as you can see here, it's like a MySQL slow query report, and we had a count query taking 120 milliseconds. And you might think like, okay, it's a read query, so it's fine. It's from a background job, so maybe it's fine. But actually, it takes a lot of database capacity while your database does that. That's one thread used in MySQL that cannot do anything else. So it's not something you want to keep. So being a Rails developer, the first thing I thought was like, oh, that's easy. Like if you have slow count queries, you use active record counter caches. It's just done for that. So what are active record counter caches, you might ask? It's a very simple denormalization techniques. Whenever you insert a record, you increment the counter. Whenever you delete a record, you decrement the counter. And so that gives you, on the parent model, that gives you like an integer field that you can just read instead of doing an extra query. It's mostly beneficial if you have like a readv use case. If you're inserting way more than you're counting, don't do it. But yeah, and so under the hood, active record does like atomic increments and decrements as part of the transaction that insert or delete the record. So it's like all atomic. It's just all keeping synced. Not for free, but for very cheap. However, when I went to track down where the code was coming from, like the query was coming from, I found that the model actually already had a counter cache, but for some reason, the code wasn't using it. And using the good old git blame, I saw that just a few months prior, someone like purposely stopped using the counter cache. So what seemed like a very simple fix started to be more complicated. So tracking down that commit and like the discussion prior to it, there was a bug report of some of collections. So it's like Shopify. So you have like products, they are part of collections, and you might not want to know how many products there is in the collection. And some people in there, would see like minus 500 products in the collection, which obviously sounds a bit wrong. There was also several linked pairs of atoms to move counter caches in Redis to try to, because Redis is atomic, so, but nothing worked so far, and that had been a long-standing bug for about a year, I think, something like that. And so I went to tackle the issue, and like all the previous atoms were like, okay, this must be a race condition somewhere in Rails. And they went nowhere. And for me, like counter caches had been in Rails like as far as I can remember. So people were using this for 10 years. It couldn't possibly be a bug in Rails, right? This was battle tested. So I went instead. I I went instead with the idea that we probably were doing something wrong. So I went to see about the implementation of counter caches, which, don't get scared, I'm gonna go over it. But this is just metaprogramming to define model callbacks. If you remove the metaprogramming layer, you get this, which is much simpler to understand, like all of you should be able to. Basically, on after create, you increment. On before destroy, you decrement. That's it, as simple as that. So I went over, like I basically audited Shopify codebase, went to look for, since those are callbacks, you could use, like update colon or like some lower level APIs that bypass callbacks. So that was my theory, but I just couldn't prove it. I spent like a couple of days looking everywhere for proof of that, but just couldn't find it. So back to square one. But then that's when it hit me that looking at the production data, like all the desynchronized counters, they were all negative. They were always displaying less than the actual count. And as you could see, many were actually negative, absolutely negative. So this already allowed to narrow down the problem. Like if we decrement too much, it means the issue is on the destroy path, not on the create. Or actually, it could be that we don't increment when we create, but. So perhaps it was indeed a concurrency issue. So when you try to reproduce a bug on a huge app, it can be complicated because you have lots of overhead and like recreating the scenario with all the validation can be complicated. So I just want to create like a small application, like your basic like blog posts with comments and whatever. And I run it with Unicorn to have like actual concurrency, because that's also a problem when you try to reproduce in development. Usually you have like many things that are different than production. And that's where I managed to actually reproduce the problem. As you can see, like the counter cache that's displayed on top says there's one product, but actually you can see two under it. And all I did this was like mashing the delete button in the browser. For the anecdote, I tried to reproduce this 10 years later for this talk, and I just couldn't because like Chrome and Firefox now like prevent double clicking. So I had to simulate it a bit. And so now that I had a reproduction, I could really look in details on what happened rather than like trying to get through like gigabytes and gigabytes of production log. I had just like a few lines. And I colored the relevant line, and you can see like the first request, which is in red, first loads the product. Sorry, I don't even remember, but like loads the parent record, like the record, and then just after that, the second request loads the same record as well in memory, and then they both delete it. So that's where the problem comes from. And as with most concurrency issues, because the job of our database of like transaction and everything is to make it appear everything like if it was a serial series of events. There's no actual, like there's concurrency of course, but like at the end of the day, you can create a linear series of events. You don't need threads or anything to reproduce. And so here, those logs translated in a simple Ruby snippet is just that. In the same process, same thread, you load you load the same product twice, and then you destroy it twice. And so I wasn't so great with SQL at the time. I just went to school, and they told me like, oh, transactions are atomic, and so yeah, that's it. But turns out it's a bit more complicated than that. In SQL, delete is an idempotent operation, so you can repeat it, and it's just gonna always succeed. It might delete something, or it might delete nothing, but in both cases, it's considered a success. So if we always decrement after delete, assuming we actually deleted something, then we decrement too much. So basically, same thing. It was very easy to create a test case to reproduce this, because when you're trying to debug something, having a good feedback loop, like a very fast feedback loop, is major productivity gain. And worst case with this test case, if I couldn't fix the bug myself, I could just like open an issue on Rails and say like, hey, here's a test case, you can experiment for yourself. So like getting a repro, like a programmatic repro is really like the most important thing you should drive for when you're looking for a bug. So now that I knew what the bug was, I was, as I said, like this has been in Rails for 10 years. It's impossible we were the first one to hit it. So I went to search for, I know I had the keyword, I could search for proper bug reports. And there was indeed some reports. There was even some proposed fix for it, like some pull requests. And one of them was to put a pessimistic lock, like use a database locking to prevent this race condition. But it was rejected or at least not considered because the performance impact of locking this explicitly during the transaction is really, really too intense. So I knew that I had to find another solution than that. But reflecting back, if you look at this like MySQL debug, like not debug, but like console session, like the answer is right before our eyes, right? It tells us that the first delete actually deleted the record and that the second one didn't. So if we could get this information from the Ruby side, we could just say like, hey, if you deleted a record, you decrement. If you didn't, you do nothing. And conveniently, we actually had this information. Maybe you have sometimes used like, the lower level Rails API, like update all or delete all and things like that. They actually return you that number, the number of affected rows. So the data was here, we just couldn't use it because since counter caches are callbacks, they don't get this information right there in a different context. So we had everything, it was just a matter of wiring, like putting all the pieces together. So I went to refactor counter caches so that they're no longer callbacks, they are actually core to active record. And this way, they could just call like the actual delete statement and get the value back and check if the affected rows is indeed superior to 0. But before submitting this patch to Rails, I wanted to test it in production because maybe my fix wasn't sound, maybe that also had performance issues, maybe there was other bugs, like as we say, a train can hide another, a bug can hide another as well. So I made a monkey patch version of that fix and I shipped it in production and I did like a data migration to reset all the counters and everything. And after several weeks, I don't remember quite how much, we couldn't notice any desynchronization whatsoever. So I was able to revet the initial commit that stopped using the counter cache, solving the slow counter in the meantime. Now that I had my fix, I had to send it upstream, right? Because you don't, like, other people can benefit from it, and you don't want to run a monkey patch forever. And I just did like a clean PR, and it fit really, really good. But Aaron Patterson ended up reviewing my pull request, but it didn't exactly go as I imagined. Based on his responses, he didn't quite understand what the bug was, which was probably my fault for not explaining well. I was a bit destabilized. So I answered very stupidly, told him like his suggestion was a terrible idea, with all due respect, so. My English, like just my proper English level, and it's just my communication skill in general weren't that great at the time. Now that I maintain many projects, I totally understand how that works, right? Because I had been working on this for weeks. I had like all the context in my head, and I didn't do a good job of like really dropping that context in the issue. Yeah, sorry. So yeah, it's really about like people cannot read your mind. It's really important to track back everything, all the important information, and put it in a good way. But lucky for me, Aaron is really nice, so he just mocked me a bit, but it's fine. But like many maintainers would have just like ignored me or something. Even I'm pretty sure today, Like myself today, I would have ignored me back in the day or something. Uh, but so the PR was ultimately merged after the consequential tree. So reflecting back on all this, there's like a few takeaways like I took for myself or whatever. It's just like debugging is just a scientific method. You just theorize, you do an experiment, you confirm or infirm, and then you just circle back until the problem is narrowed down enough that you know where the problem is. When you get more experience, you really know the application or whatever, you sometimes might do like better theories, and so you might go faster, but like the process is still the same. And yeah, I touched this a bit sooner, but like the most challenging part of debugging is to get like a reproduction. Once you get, I know very, very little bugs that have a reproduction and haven't been fixed. However, I know a million bugs where the reproduction steps are unclear or non-existent, and they're just rotting there, right? As a corollary, it means the best person to investigate a bug is the person who experienced it. Like, if you just go on a bug tracker and say like, hey, I have a bug and it's unclear how to reproduce it, the maintainer 99% of the time just cannot do anything for you. And yeah, if you go look at Rails, like you're gonna find like 5, 6 years old issues where it's just a vague bug report without no reproduction. Nobody can fix that for you. Another thing is to always question your assumption. I lost a couple days thinking like, oh, the bug cannot be that because, and just be careful about that. Another thing is that your dependencies are your code too. Like this is open source. Like Rails, it's the same thing than, I don't know, a controller that have been written by a colleague of yours and maybe he's in vacation or something, or they're in vacation. You're not gonna wait 2 weeks or whatever. It's your code too, right? You need to be able to. You don't have to know it by heart before to use it, but if it doesn't work as you expect, you need to be able to figure it out. And also, hopefully this is never the case, but like you shouldn't need to ask your manager like, can I do a PR upstream? It's your application, really. And finally. Communication is important. We all know the people who think they're like Linus Torvald or whatever, and they just can be assholes. As a maintainer, I can work on your issue on my free time, or I can do a million other things. It's just, I'm not saying like, oh, you should be polite, because you can be extremely insulting without swearing, or you can be very nice and swearing a lot. It's really about just like trying to cooperate and help and not be judgy and like keep your grumblings for yourself, kind of thing. Make me want to help you, or make the maintainer want to help you. I just need a bit of water. So, second bug, 10 years later. Yeah, fast forward 10 years, I became like a Ruby committer. I became a RailsConf member. Still working at Shopify, but in a team dedicated to work on Ruby and Rails. So I was like, nothing, no Ruby bug or no Rails bug can scare me anymore. Oh, so I thought. So March 2023, I just saw a tweet on Mastodon. And someone said like, hey, there's a bug in Mastodon, because Mastodon is written in Rails. And I had a bit of time to kill, and I was like, oh, this person is asking nicely, so I'm gonna go look. And so, classic, not super clear bug report, but like recently, Aaron Patterson had been making change to Mastodon to allow apps to upgrade. Like Mastodon was stuck to Ruby 3.1, and Ruby 3.2 was new, and he wanted to see the performance difference, so he unblocked them to upgrade, and some users started to upgrade and starting seeing weird errors, like actual exceptions. And this is the backtrace, and like I was just reading it, and it's trying to, like it's failing. Like without looking at the code, it's failing trying to read the ID attribute of an active record instance. So to me, like I just like, oh, this is simple. I was very overconfident. I'm like, oh, my student developer simply run into small limitation. Like, of course, I said like, oh, this is probably one of your model that doesn't have an actual ID attribute. Maybe it's just like a join table. I'm just gonna fix that in Rails. It's no problem. You can just work around it that way. And of course, like 5 minutes later, while trying to do the change in Rails, I was like, wait a minute, that just doesn't add up. I ignored tons of clues in the thread, and I just jumped to conclusion way too quick because I was clearly overconfident. When I went to look at the source code, the problem is not the model doesn't have an ID colon, but that we're trying to access the ID of an instance that didn't have its attributes values loaded yet. So it was like a partially initialized recode, much weirder than just that. Another clue that I have been totally ignoring is that it was only happening to people upgrading to 3.2. So like the Rails limitation was totally off track. So I had to come up with a theory that would include the upgrade, like the change between 3.1 and 3.2 as a bug. Since the bug was triggered by Marshall trying to load the cache, I went to look for the changes in Marshall. So a good old git log thing, and looking at the commit, there was basically nothing. And honestly, from experience, when you're starting to use git log to try to find a bug, it's just like you're desperate. You have no idea where you're looking at. This is never or you find bugs unless you know it's really between like 5 commits. But 1 year worth of change, it's like, forget it. So at this point, I just didn't think I could go any farther without reproducing, because here I was trying to debug something that wasn't happening to me. So it's just like trying to help your parents on the phone to debug their internet box or something. It's just absolutely terrible. So I needed to, if I cannot reproduce myself, I cannot go any further. The next day, another user posted like an interesting observation. They tried to load the broken Marshall payload from Ruby 3.1. So like they took a cache payload from production and tried to load it in the old Ruby, and it was failing the same way. So this was one more clue, right? We knew, I mean, I was convinced the bug was in Marshall, but I didn't know if it was a bug in loading the Marshall or in serializing it. And so if a payload generated by 3.2 is still broken in 3.1, then I know it's in the generation. So we halved the hypothesis yet again. But I really needed my hands on like a corrupted payload, because I would needed to inspect it. The problem is Mastodon cache contains lots of like personal identifier data and stuff like that. So you cannot just like, hey, take this, because that may be private messages, that may be like. So the next day, someone shared like a decompiled payload, like it's basically like a AST of the payload. So I couldn't execute it, but at least I could see, like they did this so that they could strip the personal information. So at least I could have like a various clues about what it looked like. And that led me to a new theory, is that in the payload, I could see there was many circular references. I'm going to touch a bit more on that. But basically like object reference, like A referencing B and B referencing A. Marshall is able to handle that. And so my theory was that an active record instance was being used as a hash key before, like in a circular way, before it was fully instantiated. So basically that would look like this pattern. Here, if you're not familiar, allocate, like when you do some class.new in Ruby, basically it calls allocate and then it calls initialize on the return of allocate. So here I'm allocating an object without initializing it, without calling the initialize. And if I use that object as a hash key, I had exactly the same error I had, like users had in production. So that was a confirmation. So you need to understand a bit how Marshall works. Like it's not a magical thing of where you call load and then instantly all your object graph has been recreated by Marshall. It just reads it's a stream of instruction on how to recreate the object graph. So it creates the objects one by one and then just rebuilds the graph. which means that like many points in time, you have many partially initialized objects. And because of this, in case of circular references, it may have, like Marshall may have to insert a partially initialized instance as a hash key or something. So that was purely a theory at that point, but something like that could reproduce. So I had a pattern that could explain it, so I need to look for it. Since I know Active Record relatively well, I had a few ideas of where the thing could be, and so I started greping and things like that. And one place where we use Active Record instances as hash keys is association cache. When you load like products.comments or something, there's a hash with instances as keys. But there was a missing piece, right? Is because for, like, okay, the record was partially instantiated, but it means that we would load an association cache before we load the attributes, which made no sense because if you were to create a new record and look at the order of the attributes of the instance variables, attributes are before. So we would need also to find a place where the ordering differs. But like, let me show you ordering. You probably never ask yourself this question, but like, all instance variables are ordered in Ruby. So at the surface, it's quite simple. Ruby just preserves the order of association. So here we have like two classes, A and B. One define, they both define in reverse order, and when you ask for instance variable, you get the order you set the variables. But what if the same class can sometimes have different insertion orders? Like in this case, it's the same class, and in one case we define A and then B, and in the other case we define B and then A. And you can see that like the first case is what we expect, but that in the second case it's less clear, right? Like, should you reuse the same order than from the first instantiation, or do you have your own order because you're a different instance? On the Ruby committer Slack, we have a very useful bot where you can give it a snippet of Ruby, and it's just going to run it over all the versions of Ruby and show you the differences. So if you ignore the 1.8 where this was returning strings, you can see that in 3.1, up to 3.1, the very first insertion order seen by the class was preserved, and the same for every single other instance of the class. But in 3.2, that changed. In 3.2, every single instance have its own order. So this was a smoking gun because we have a difference between 3.1 and 3.2. And the reason for that is object shapes. I work closely with two colleagues of mine were working on that. This is like a optimization. So now we needed to find a pattern in Active Record where we could cause this. And I groped for it, and I thought I saw it because I saw like, oh, there's this initialized up. When you dupe a record, it resets the association cache and then calls super, so all the attributes are set later. So I was like really, really excited. Like I found the bug. I had like so many exclamation points. But actually I was wrong. When you dupe, actually, like the attributes are copied directly and then the callback is called, so it just didn't work. But, oops, sorry. But then, thinking about it more, what happens is that I had been messing in my console for a very long time, and I created a state that was reproducing, but just that wasn't it. And the mess is that it's a bit complicated, but like shapes are an optimization unless you define your attributes in such a different order every time that it creates so many possibilities. And when that happened, Ruby de-optimized and said like, okay, I'm just going to use a hash, for that because it's too complicated. Otherwise, it makes a gigantic tree. And so to reproduce this, you had to create so many different insertion order on that particular class so that it will de-optimize the class. So I had finally, after 4 or 5 days, I actually had my repro. So arguably, complex object being unordered, it's just a bug in Ruby, right? It's a bug in Ruby, not in Rails. We should fix it in Ruby. It has been working since then. But also, like, Rails 7 was just new. I couldn't say, like, oh, don't upgrade to Rails to Ruby if you're using Rails 7. It just doesn't work. So we need to fix it in Rails as well. And I saw, like, this is like, in Insight, like the actual fix we did in Ruby just shipped like 9 months later or something. So that would have been terrible not to fix. So I needed a quick workaround for Mastodon users. I needed a fix in Ruby, and I needed a fix in Rails. At that point, I was curious because at Shopify, we had upgraded to 3.2 for like 3-4 months, and we never hit that bug. But it's because we don't use Marshall. We basically banned Marshall for this sort of reasons. We use a library called Paquito. And so I thought, okay, I'm going to backport something from Paquito into Mastodon. So basically, I just replace, instead of just doing Marshall dump, I replace with a custom serializer. I'm just going to show you very quickly how it works. It's just like every record is basically an array with like the class name, the list of attributes, and your record, and then we rebuild it cleanly from that. We don't rely on Marshall resetting with the order and everything. As an added benefit, it was like way faster. It was like the payloads were twice smaller, and the serialization time was also like cut in half, more or less. So I basically then did pretty much the same thing, but for Rails itself. Of course, the payload is different, so there's like a migration step. You need to activate the new version and everything. But now it's fixed for everyone in Rails. And I even did kind of a beta version because you can control all, like object can declare all their serialized by Marshall. So it's still using Marshall, but it's not using the automatic kind of thing. It just say like, oh, if you want to convert me to Marshall, you just convert it like this array with 3 elements. And similarly in Rails, that cut down the payload and the serialization time quite a bit. So now we needed to fix it in Ruby. So, I mean, Thunderlove broke it, so I told him to go fix it. And the issue is that when Ruby deoptimized and said like, oh, I've stopped using shape, I'm going to use a hash, it was using an unordered hash. Like technically it's an order hash, but not an order we care about. It's not the initiation order. The patch is much more complicated than that because it's C, so you need to fix things everywhere. But basically, it changed the type, right? Instead of using ID table, it's using ST table. It's exactly the same hash you're using when you're using hash.new in Ruby. It's really the same thing. And the fix was then backported in 3.2.3. So yeah, just to finish conclude on this, some more takeaways. I really need to double check before posting because like this thread, if you go look it up, it's like all of me saying like, oh, I found it. And 2 minutes later, like, oh no, I was wrong. Just made a bit of a fool of myself. And also before I said like, oh, when you get more experience, you know the system well, you might be able to take shortcuts. Beware because you might actually discard some information because of that. Also, as I said before, it's way harder to debug something you're not experiencing yourself. Like, it's really, really awful. If from day one I had a corrupted payload, I would have saved like 3-4 days of debugging. And to me, it's like the big advantage of open source. It's just like, you can directly debug yourself. You're not just trying to do back and forth, slow back and forth with other people. Be very careful with Marshall. It can be convenient, but like it's really, really dangerous. Honestly, my advice would be like, if the thing that's going to deserialize what you serialized is the same program with the same version, it's fine. But even across two versions of the same program, it starts to be very, very dangerous because maybe it's referencing a constant you removed, things like that. So try to avoid it like the plague. I saw like, it's more for Ruby, but like semi-deterministic behavior is really the worst because like this is what made it so hard to reproduce. And also, just because you're trying something with Ruby and it works, and maybe it has worked like that for 5 versions, doesn't mean it's going to continue like that. Like if the documentation doesn't tell you that the insertion order can be trusted, you shouldn't trust it. There's something called Irum's law that says like every single observable behavior of your program will end up being relied upon by one of the users. But exactly what was happening. And yeah, it's never a Ruby bug. Like, don't go out of this talk thinking like, oh, I know the weird thing I'm seeing must be a Ruby bug. It's never until it is. And yeah, the Ruby VM is your code too, because your code's running on it. If it's buggy, your program is buggy. So just be curious, just go dig in how things works and just, yeah, search into it. That's all I had. Thank you very much.
Oh, we're doing this, folks.